I actually don't know what I'm doing here.
Do I need to make jokes?
Yeah, sure. Make jokes.
I don't have.
Hello, welcome to my TED Talk. Okay. I'm trying to do the intro to Langchain. I'm not sure if you guys know Langchain or worked with Langchain. Anyone can raise your hands if you tried Langchain. 1, 2, 3. Okay, I'm comfortable then. My experience with Langchain just started like this year, I guess. And I tried to apply it to a number of projects, pet projects that I had. And I learned a bunch of stuff with it. So here's my TED Talk about it. Langchain and rapidly prototype LLM powered apps. So here's our program for today. We need to know what the heck is Langchain. Langchain, the problem for this session is introduce you Langchain as a framework, then we'll get to know what chains are. Documents and vector stores will be next in line, then we'll talk about the agents themselves, and we'll try to do a demo if we have time and room for some questions. So what the hell happened in the last 3 years of AI? Suddenly we have all these disruptive products on the market that generates all the text for you, and you don't have to do a thing. Well, I remember James Cameron doing this movie called Terminator, which actually doomed us all into a Skynet that tried to kill us all and replace us by robots. But nowadays, it's 2024 and we have this. And this is a text generation bit. And so can we consider LLM as an AI that can kill us all? Not really. I consider LLMs to be like this, like parrots, trained parrots to talk to us. But meanwhile, they are not reliable. They're like hallucinate and stuff and tell us wrong stuff because they're focused on generating text. And the ones that win with this are processors like NVIDIA, which stocks just go up and up and up. And now we have something like this hogging our memory and processors and hogging all the energy from us. Worse than node modules if you guys work with GS. Thank you, Andre, for the joke. And so are kind of like here. We're not being replaced, but where are we? So yeah, forget about that doomsday, and let's just bring us the Langchain part. And let me just bring out the Langchain. Let's talk about Langchain finally, and because all of that before just didn't matter much. Langchain is a framework, and it's supposed to be agnostic to LLM, so you don't need to actually think about working for an OpenAI LLM or a bot from Claude AI or Gemini. Langchain is here to actually abstract that stuff from you, and you just need to know that I'm configuring this to use this LLM or that LLM. It has Langchain framework provides you with access to diverse tools, and we'll talk about it more in depth. And it's focused on automating chains of actions. And another thing that I have to talk to you is that Langchain framework provides you with 3 main packages, like Langchain Core, which is responsible for all the abstractions. The Langchain community, which is responsible for third-party integrations like OpenAI, Claude, or Gemini, or even models from Hugging Face, which are open source models that are available for you, I think. or even models from Ollama. Ollama is a thing that you can install on your computer to run models, although you probably don't have the computer to run it, unless you opt for a model that has the lowest of parameters. But more on it on another talk, because it's very interesting. Langchain itself provides you with a bunch of tools like templates, chains, retrieval, agents, and other tools like summarization, memory, and callbacks, and we'll get to them pretty soon. So for now, prompt templates are a concept that you guys need to get on your head. They're supposed to be they're supposed to provide context and be flexible. And you construct them like this, like an array that tells you which type of message they are. The templates, we have 3 types of message: system, human, and AI. And the AI is supposed to be the LLM response. The human is you, as your prompt. And the system is context, for you to provide some context to define what are we doing. And now the basic usage of Langchain is picking up a prompt template that you defined before, and then you provide it to the model, which is the LLM in this case, and the LLM responds to you. Like, you provide the prompt is put on the LLM communicates you back with a response, and then you parse it with a parser. And you can use something called piping, which is what Langchain language provides you, the syntax, and we'll see it in a bit. Let's see. So this is a demo, and I already installed the package here, and you can see, maybe I can do a zoom in. Is it okay? No, it's not okay. It overlaps. All right. Maybe like this. So provided that you have an OpenAI API key, they're not for free, but they're not really that expensive. You can initialize the chat, a model here, and you can initialize your prompt here, which is a template. In this case, it's not an array, it's just a simple phrase. You see that there's a country here, which is a placeholder that you can use. And from there, you can, as said on the slide, you can actually construct your chain with prompt piping. This is a piper. This actually outputs to the next in line. Prompt pipes to the model gets the prompt, communicates to the LLM, and then gives an output, and you parse the output with the str output parser. So let's try it. Let's try. This is scrolling. This is not scrolling. This is not scrolling. What the heck? Of course, you're going to do this. So let's try it like this. The chain is built. There you go. So let's invoke the chain for the parameter Portugal. What's the capital of Portugal? And there you go. The response is Lisbon. So this is how essentially a template works. You can actually now replace the parameter country for New Zealand. And the answer is Wellington. Yeah, you guessed it. Now there's Azeroth. And you guys don't know where Azeroth is, right? Stormwind City. Okay, this is the gist of it. Is it? I don't know either. All right, so this is piping. This is how you construct a chain. Let's go next. But there's a new concept now, which is compose chain. And compose chain can actually pick up your existing chains, pipe it together to another chain, and then you can have this montage of inputs and outputs running through a bunch of LLMs. And there's a demo here. We're going to try and do a prompt chain with communication from between two LLMs, which the first one will produce you a code, and the next one will produce you a test unit. Let's run it. We construct the chains, and then here we see that we're constructing a compose chain. Let's run it out. Basically, the code chain output is going to the parameter code. Then the second chain test prompt will pick up the code parameter here and run it through the model again with the test prompt and parse it. Let's see it. We construct the chain. Now we print the first one. It has print. I tested before, of course, so it has the output. So this is the function that the code that produces what you need, and then the code that actually tests it. And there you go. Maybe the prompt here could be a little bit better because it's supposed to be a function and not just code. So you can actually tune your prompt out to improve it. So this is a compose chain. Let's go next. There you go. Parkour, because compose chains. And, you know, that was a struggling joke. OK, now the concept of document loaders and text splitters. These will be useful for you if you want to contain the LLM response for your app. Because LLM contains a lot of information, and sometimes you don't really want to just give him that freedom. So, because imagine that you have a document, and it's a manual about constructing your bike, and you ask the LLM for instructions to actually mount the bike, and he gives you instructions for a motorbike. That doesn't make sense. So you need to provide more context. And you use, what you want to use is like scan all your bike manual, probably into a PDF or a text Word, and you use a document loader for that to load it into memory. And then you need to split it a bit. So the purpose of it is to actually not send a whole document every time you want to ask the LLM for stuff. So you don't run out of tokens like pretty fast. And yeah, in this case, we use a text splitter to section our document into chunks of the size we want. We can actually parameterize these chunks. We have another parameter called chunk overlap that we can use to actually provide you an intersection to smooth out chunks that you then will give to the LLM. And for more information, let's try another demo. So vector stores, let me just clear this up. In this case, this is jumbled text. I'm sorry. Google, please. Oh, well. So in this case, what I'm doing with this code is just I'm searching for a document called facts.txt, and we'll see it in a bit. Drive. Yeah. Never mind. It's a lot of documents. But essentially this facts.txt has 500 facts. And I just want to query my LLM for these facts. And the way I do this is to section this facts.txt, which is a lot of facts, to just shove it to the LLM to answer. And I want to store them into a vector store. A vector store. But before that, I need to load them as a document and split them into with the resorting to text splitters. And in this case, you can see that I can provide the chunk size that I want, which is 150 characters. You guys are not, maybe this is, never mind. Chunk size is 150 here, and chunk overlap is 50, which means that you separate your document, in this case text document, into 150 characters. But then when you separate them, you don't really separate them exclusive. You can actually overlap the separation, which means that the last part of the first separation, of the first chunk, it's actually included on the second chunk. And this provides you with a smooth transition of chunks between one chunk and another chunk. And more on the vector stores, I essentially wanted to actually show you this part, which is, this is the output. It tells me that created a chunk of a bigger size because it couldn't actually create a smaller size, because I provide also a parameter called separator, which is /n, and it essentially follows that rule. More on that. Okay, vector stores and retrievers. Yeah?
When you said there's an overlap of 50 at the start, 50 at the end? Or?
So the first section would be 50 at the end. Like it's 100, from the beginning to the end, 150 as possible. And then the 50 characters would mean that the second separation would be overlapping the first separation. So a bit of the end part of the first separation would actually appear on the second chunk. So we now have a bunch of chunks, and we need to actually convert them to language that the LLM understands. And for that, we use this thing called creating embeddings. We create embeddings with resorting to the LLM itself. The LLM will actually apply its training data to create the embeddings. And then we pick up the embeddings that are created and store it in the vector store. Which means that the vectors here are like an array of numbers that only the LLM understands. And they are related to chunks. In this case, chunks we understand, vectors are their language. And if we actually store the relation to them, it becomes easier for the LLM to actually understand what this means. And if you use a database, a vector database, and we store this kind of language, we can also do it ourselves, queries to the vector database. In this case, imagine that we want to actually prompt something and search for context. And context would be chunks, in this case, chunks that are in the vector store related to embeddings. And we need to calculate the similarity between our prompts and the chunks. And we use something called search for or query for similarity, which will actually provide us with all the chunks that are more related to the prompt that you have. And we'll see this working right now. So please, yeah, you created a lot of chunks. So let's call it a database called Chroma, and we we'll create the chroma from documents that we loaded into a persisting directory called embeddings. This is the folder. It created, I have a query here, and I want to, so this query is my prompt, and I want to do a similarity search with score, which means that, as I told before, I want to get the chunks that are more relevant to my prompt. So I can actually do a very cute technique here. So, get me a fact about Superman. Remember, this is a 500 facts document, and it tries to actually give me something, something about William Marston. I think it overlaps a bit, so, oh, cool. Yeah, it's not working because it needs to reset the embedding. Let me just delete the folder. There you go. Hello. Refresh. So it's important that you don't have it persisting much. Please. Okay. Rename. Yeah, sure. Rename folder. There you go. So let's try it again. Hello. Okay, persist correctly, please. Create chunks. Create the chroma database, and it actually fails me. All right. Sorry? Okay. Thanks. There you go. Pair programming, guys. Yeah, never mind. So essentially what would happen is it would actually provide me with 4 results, which would actually have somewhat to do with Superman, and one of the facts would be in every episode of Seinfeld, there's a Superman illusion. Yes?
Go to the one that you renamed. I think you had a file called chroma, and that I think that's the why you have the problem. Yeah, that thing. No, I think you need to put that on the
Oh, okay.
I mean, I don't know.
I'm gonna try it, I guess.
Just try it anyways.
I don't have much time, but I was about to quit. Anyway, we had it running on Meatballs, so. Yeah, never mind. Never mind. Okay, so almost. Is there anything here? Hello?
Oh, it's something about Wonder Woman.
Yeah. Something.
It's in the same universe, it's fine.
Yeah, it's fine. No worries. The thing is, it's not working, but
Every episode of Seinfeld.
there you go. This is the output that was before. So essentially, you'd actually retrieve the results, the chunks, then you provide the chunks together to the LLM. And yeah, in here, you actually print the results. And then what happens would be you create a template with the context, which would be all the chunks that were provided. The question would be something like, get me a fact about Superman, and the answer, it's not going to work, but yeah, the answer would be something relevant to the facts txt. Anyway, time is over, almost. Let's talk about agents. So, in this case, I would say fetch relevant chunks, and it would be together with your prompt. The LLM would be then provide you the output. Science. So agents. Agents are Langchain systems. They provide you with some leverage together with LLM, like a little bit of a cycle, until the LLM is considers that it's satisfied with all the information that it has, and then provides you with a response. And we'll see it right now. So essentially, agents work with tools that you actually define with a function, for example. The function could be a simple math or a multiplication function, or even an API function. And you provide the prompt. It begins this cycle between the LLM and the agent. And then when the LLM says that it has enough information, it provides you with a response. So let's say I have this function that checks for the weather in the site weather.biz. The agent tells the LLM that it has this information that you can use. And then I create a prompt, something like, is it colder in Faro or in Auckland? And the LLM then asks the agent to get the weather in Faro, so it calls for execution on that function. The agent tells it that it is 38 degrees. Then the LLM asks again for the weather in Auckland. The agent replies it's 14 degrees Celsius. And then the output from the LLM, it considers that has enough information to reply. It says it's colder in Auckland. Let's, again, parkour. Let's see if this thing works. In this case, I have all this function here, which I define as a tool. I have a function called getWeather. It has, it's important that I say what type of parameters and outputs it gives. And it's also important to document what it does. Because this tool is an annotation that will actually help you with information. So essentially, I have this API. I call the API here. I get the response, and then I give the response to the LLM. I don't even read it. I just put the JSON there. Let's do it. Define the function. Define the tools array. Here I define the prompt template, which reply in short message. I leave room for input and for the agent's scratchpad. And you are twitching a bunch. And now the query is it colder in Faro or in Auckland? And it's actually communicating. So input is it colder in Faro or in Auckland? Output is it's colder in Auckland with a temperature of 12 degrees compared to Faro, which is a temperature of 24 degrees. So all of this information was just provided right there because the LLM basically asked us to do 2 API calls to see the weather in each location that I asked. There you go. So that's it. We ran out of time. We could talk more about chat memory, summary, and file stored history. We could actually juggle with that to actually provide a chatbot. A chatbot would be useful to have these tools. Callbacks would be amazing if you want to actually see what's behind the curtain, what prompts are getting to the LLMs. There's Langsearch for API if you want to actually provide a server of Langchain functions to other systems that are not in Python. And that's it. There's a lot more tools that we could actually go through. The demo time is done. No worries about it. Okay, guys. Thank you. There's some sources of information. There's some sources of information that we can provide you in Discord if you want. I don't have a QR code for this. I don't have time for that. But yeah, join our Discord in GeekSessions if you guys want to know more about this, because there's a lot to learn. We actually do a lot of work with Langchain here in these workshops. We plan to do more. And thank you very much for listening to my ramblings. Yeah, I had this slide saying that if you actually want to know more or work with us, there's this meatballs thing that we do every Wednesday, and we try to do these mini workshops that are not really professional or that stuff. They don't really need to worry to be professional. We just want to do things. We want to play with things, and just try to learn new things, because the universe is fast enough to actually come up with new things all the time. Thank you very much. Thank you for Local Foundation to provide me with this template and to provide me with this clan that supports me every day. And thank GeekSessions for having me. And thank Turbine Kreuzberg for having me also. Thank you.